Hello my dear friends, welcome to Science Academy. Today we are going to solve Unsolved Example 6.3 of Chapter 6. A long solenoid with 15 turns per centimeter has a small loop of area 2.0 centimeter square placed inside the solenoid normal to its axis. So friends, here long solenoid is given having number of turns n is given as 15 turns per second. If the length of the solenoid is 10 centimeter, then the total number of turns in the solenoid becomes 15 into 10 equal to 150 turns. यहाँ पे जितने भी सेंटीमीटर सोलेनॉइड की लेंथ होगी वो लेंथ को 15 से मल्टीप्लाई करेंगे तो टोटल सोलेनॉइड में कितने टर्न्स होंगे वो हमें मिल जाएंगे, राइट। क्योंकि यहाँ पे 15 टर्न्स तो है लेकिन वो पर सेंटीमीटर दिया है। Has a small loop of area 2.0 centimeter square. The area of small loop is given as 2.0 centimeter square. तो कीप इन माइंड यहाँ पे नंबर ऑफ टर्न्स है तो उसमें पर सेंटीमीटर में है और एरिया जो भी है वो भी सेंटीमीटर स्क्वायर में है. So here we have to convert it in meter. Then we can calculate the example, right? Now, if the current carried by the solenoid changes steadily from 2.0 ampere to 4.0 ampere in 0.1 second. So friends, here the value of current is changes from 2.0 ampere to 4.0 ampere in 0.1 second, right? So here we have two values of current I1 and current I2. The change in current di, which is equal to I2 minus I1, means 4 minus 2, and ultimately it becomes 2 ampere. So di is 2 ampere, and the change in time dt, which is given as 0.1 second, right? What we have to calculate? What is the induced EMF in the loop while the current is changing? So here we have to calculate EMF E, okay, and by using the Faraday's law of electromagnetic induction, EMF E is given by d phi by dt, and from this equation we can easily calculate the EMF induced in a loop, right? So let's calculate induced EMF in a loop. So here we have this data available with us: number of turns n, 15 turns per centimeter, area A is given as 2 centimeter square, I1 which is 2 ampere, I2 is 4 ampere, change in current I2 minus I1 which is equal to 2 ampere, dt change in time which is equal to 0.1 second, and one additional parameter which is helpful for calculating induced EMF in this example, which is mu 0, permeability of free space, permeability of vacuum, which is given as 4.4 pi into 10 raised to minus 7 Henry per meter, right? And here we have to calculate the EMF E. Okay, so let's convert this term in meter. So number of turns n is given as 15 turns per meter. If I want to convert in meter, it becomes 1500 टर्न्स पर मीटर. यहाँ पे सेंटीमीटर है, अगर मीटर में कन्वर्ट करेंगे तो क्या होगा, 1500 हो जाएगा. सेंटीमीटर को मीटर में कन्वर्ट करेंगे तो क्या होगा, 0.01. ये 0.01 डिनोमिनेटर में आएंगे तो ऊपर मीन्स न्यूमरेटर में जाएंगे तो क्या होगा, 1500 हो जाएगा. वेरी सिंपल. And area A is given as 2 centimeter square. If I convert it in meter square, then it becomes 10 raised to minus 4 here. So area is 2 into 10 raised to minus 4 meter square. Very simple. Okay. So let's calculate EMF E by using equation d phi by dt. So E equal to d phi by dt, and we know the flux phi which is equal to A into B, or you can say B into A, where A is the area of the loop and B is the magnetic field. Now tell me, on which parameter this magnetic field depends? There are basically three parameters on which this magnetic field is depends. First is mu 0, permeability of free space, then the number of turns of the coil, and the current flowing in the coil. On these three parameters the value of magnetic field is depends. So I can put mu 0 into n into I in place of B. So ultimately flux phi which is equal to A in bracket mu 0 n into I होगा. Okay. So Here the value area is constant mu 0. We have the value of mu 0 which is also constant. Number of turns in the coil which is also constant. The variable term is only this current I, and here the variable term current I means we have two values of current, I1 and I2. Okay, so in this case the differentiable term is only this current. Okay, so put this flux phi, equation of flux phi over here. Okay, so E इक्वल टू ए इंटू म्यू जीरो इंटू एन इंटू डी आई बाई डी टी होगा, क्योंकि यहाँ पे करंट आई ही डिफरेंशिएबल टर्म है, तो अल्टीमेटली ये डी आई बाई डी टी यहाँ पे हो गए. ओके, सो नाउ वी हैव ऑल दिस पैरामीटर अवेलेबल with us. Okay, so simply just put in this equation, we can easily calculate the value of EMF induced in a loop. Okay, so area A is given as 2 into 10 raised to minus 4 meter square. So area is 2 into 10 raised to minus 4. Mu 0 which is given as 4 pi into 10 raised to minus 7. 4 pi into 10 raised to minus 7. The number of turns N is given as 1500 turns per meter. Here the 1500, and change in current DI which is 2 ampere. Here current, change in current which is 2 ampere, and change in time dt which is given as 0.1 second. Right. After evaluating this term, we will get the EMF E which is equal to 7.54 into 10 raised to minus 6 volt. So here we have calculated EMF induced in a loop by simply using the equation E equal to d phi by dt according to Faraday's law of electromagnetic induction. Right. Thank you.